Friends, so here I am Arko sir. So I have come with another new episode. Okay, on the topic light. Okay, so in my channel PT Scholar. So if you have missed my previous episodes, okay, I have uploaded some episodes on light. Okay, so if you have missed, so subscribe my channel and you can see all the episodes. And my objective is to clear your concept and doubts, okay, on the topic of physics as well as biology, okay. So both the subjects I am uploading topic wise, okay. So if you continue in my channel, okay, then I think all of your doubts and concepts will be clear, okay. And what type of videos you want from me, you can write in the comment section. And if you want the quality notes, then also you can send your mail ID, okay, it will be provided, okay, to you. So today the topic is dispersion and scattering of light, okay. I have completed the chapter prism, I have completed the chapter lens, okay, and also I have completed prism and lens and also the mirror, okay. And now it's the dispersion and scattering of light, very important topic. So in case of the prism, what we have seen that when a ray of light, if the surrounding medium is rarer than the medium inside the prism, okay, then the ray will bend towards the base of the prism, okay, the refracted ray or imagined ray. So now, if suppose this is the prism, if a white ray of light passes, okay, refracted to the prism. If the white ray of light refracted to the prism, then what will happen? White ray of light refracted to the prism, okay. So it will be split into 7 different colors, okay. It will be split into 7 different colors. 7 different colors, okay. So if it is white ray of light, incidence on a prism, then on the other side, okay, what we will see, we can see the 7 different colors of light. So at the top it will be red and at the bottom it will be violet, okay, and all the 5 colors will be in between, and the middle it will be yellow, okay. At the middle it will be yellow. Clear? So at the top, that the red color light will be there, and at the bottom, okay, towards the base, it will be the violet color, and we can see the yellow color as the middle. Okay. So the white color ray will be split into 7 different colors when it will pass through a prism. Okay, and the imagined ray will get 7 imagined ray for one single white color of light. Okay. So this phenomenon is known as dispersion of light. Okay, so what is dispersion of light? If a white ray of light passes through a prism, then it will be split into 7 different colors. This phenomenon is known as dispersion of light. Okay, now next point is cause for, understand this, cause for dispersion. Okay, a reason, okay, so causes or reason for dispersion, okay. So if light travels through any medium except the air and a vacuum, okay, all the color of light travels at the same speed, okay. But if the light is traveling through any medium, okay, except air and vacuum, then the speed of light for different colors will be different, okay. The speed of light for different colors will be different. And what do we know? Refractive index mu is equal to speed of light in air or vacuum divided by speed of light in that medium. Okay, so that is what the refractive index that I have discussed earlier that what the refractive index of any medium is speed of light in air or vacuum divided by speed of light in that particular medium. Okay. So speed of light in the particular medium for each color of light is different. It is not same. It is different. That means what? The refractive index. So the refractive index of each color of light will be different. So the speed of light as speed of light okay, in a medium except vacuum or air is different for different colors, different color of light. So refractive index will be different, okay, for each color of light. So refractive index mu will be different for each color of light. Now the angle of deviation delta actually depends on the refractive index. So if the value of difference is small, then the light will deviate in a less angle of deviation, lesser angle, and if refractive index is big, then light will be deviated at a more angle, then the angle of deviation will be more. Okay, so what will happen? So if refractive index is small, then angle of deviation will also be small, and if refractive index is greater, then angle of deviation will also be greater. So what is happening when a white ray of light enters into a prism, then what will happen? That as the speed of different color of lights will be different, so the refractive index of for the different color of lights will also be different. Okay. Now the color for which the refractive index is small, the angle of deviation will be small. Okay. So red. The refractive index of red is smallest, okay, among all the 7 colors. So the angle of deviation will be smallest. So red color will be deviated in a smaller angle, okay, and the refractive index among all the 7 colors will be highest for the violet ray, okay. That's why the angle of deviation will be highest among all the 7 colors. So what will happen? All the different 7 colors will be deviated at different angles, though they will be splitted from each other. Okay, and they will come out from the other side of the opposite sides of the prism. Okay, so the top, as the angle of deviation is smallest, so at the top red light will be there. Okay, red color light will be there, and at the bottom, as the angle of deviation is maximum, so the violet color light will be there, and in between all the other colors as per their angle of deviation, it will be arranged, and at the middle position the yellow color light will be there. Okay, that is the mean. Okay. So at the middle position, the yellow color light will be there. So I think I can explain the angle of the reason for dispersion. Okay. So what is the reason for dispersion? I am explaining once again. So the velocity of the light in a medium except air and vacuum will be different for different color of light. Okay. So when a ray of light, that means what? The refractive index will also change for different color of light. So the refractive index, if it is small, then the angle of deviation will be small. If refractive index value is bigger, then angle of deviation will be bigger. Then by that color of light will be deviated at a maximum angle or more angle. Clear? So that means what? When the ray of white ray of light enters inside the prism medium, okay, then what will happen? Their refractive index of all 7 different colors will be different. So the angle of deviation of all the colors will be different. So each of the colors will be deviated in different angles. So the angle of deviation of red light will be minimum and violet will be maximum. That's why red will be at the top and violet will be at the bottom. Okay, and yellow will be at the middle. So this is the reason for angle of dispersion of light. Okay, so I hope you have understood this. So next, coming to the next point. Now next point: can a prism prism create different colors of light. Colors of light. Okay. Suppose this is a prism. This is the prism. Okay. This is the prism. If suppose the red color of light, so what? It will be also red. So no dispersion will take place. Why? Because it is only one color of light. So the refractive index, okay, of red light will be same. Okay. So angular deviation for this particular light will be same. So only one color of light will be will get as an emergent ray on the other side of the prism. That means the prism cannot create any new color of light. Okay, white color of light consists 7 different colors actually which you can see. So it can only separated. It can only be separated. Okay, all the colors of light, and that we can actually see. Okay. Now, what is the experiment? We can